Hi, everyone. Welcome to the Thoughtful Software Podcast. My name is Fahad, and joining me always is Andrew Wolf, CEO of Skipless. This podcast is all about building great software, thoughtful software. It's unfortunate, though, in the software industry, billions and billions of dollars a year are wasted on software projects that are essentially unusable. It's a staggering amount of value that's lost for our economy, our companies, individuals. It's absolutely ridiculous. And we feel there is a better way, and this is thoughtful software. So, in this episode, we talk about my favorite topic. I love this topic. It is Internet of Things. In this episode, we also talk about what is IoT, what you can expect from an IoT project if you want to start something like that. What are some good best practices? Just things to look out for, just our thoughts on IoT. Again, I absolutely love this topic, and it's something that's going to impact our lives a great deal. So let's get started. Here we go. All right, Andrew, good to talk to you again. Today we're going to talk about something that's very near and dear to me. I started out in electrical engineering many, many years ago and spent quite a bit of time in wireless communication. And one of the things that was just most fascinating to me was the Internet of Things. And what gets the most attention these days is, things like Fitbit and Apple Watch and the Nest thermostat. And that's really how people think about IoT. IoT is going to almost affect every aspect of our lives. And so I think it's an interesting topic that just recently came up, and we thought it'd be good to talk about it. Uh, Maybe you can kind of talk about your thoughts on IoT, just how it's going to impact users and why you think it's so important to us.
Yeah, absolutely. So we're seeing a lot of uptick in demand from IoT customers. We even have a primary uh, firm we partner with to help us design products for people. It's really transforming the way we think about everything. From farming to the way you drive to work to the way you bicycle. The amount of data you can get from devices is incredible. And it's some of the data we've been lacking over the last 30, 40 years in computing. We had talked last week about data biases and data science and AI and things like that. It allows us to enable a new world almost through everything we collect, from bicycle helmets to the NFL is transforming itself with the way it treats players through IoT devices. It's just an incredible shift in the way we think about the world and how we think about computing too, and how we can use physical devices to just transform the way people live.
Well, what are some of the examples that is really going to be impactful? Like, here's a few things I can think of, like just cars, obviously. Well, let's think about like road health. I was reading somewhere that cars would be able to predict when a pothole might happen. And so there's all these other services that are going to happen based on that information. And, you have things like that that people really just aren't thinking about. And so I think it's interesting, where almost in every aspect from hospitals, roads, communities, everything's going to be touched by IoT.
Oh yeah, absolutely. So I live in Northeast Ohio, and we're no strangers to snow over here. If you look, a lot of cars can start reporting the condition of the road to the city and the state, sometimes the county over here, to make sure that the roads are high quality during the winter. Cut down a lot of vehicle wrecks and deaths. That's one way it can be used. And hospitals, the Cleveland Clinic right by me is using IoT to transform the way they treat patients. The beds now report a lot of vital signs that they didn't have before back to nursing stations. So then, before a person has a heart attack, and they can go treat the patient early, and there's a lot of early prevention. And with data like Fitbit and Apple Watch, they're able to predict health issues and chronic health issues that they weren't otherwise able to get insight into before. I mean, the possibilities I mentioned before are endless when you combine the physical world and the virtual world, and IoT is how we manifest that. And it's just, as you mentioned, hospitals and roads are just one thing, but self-driving cars are enabled through IoT sensors, and they just get better as roads and signs and stoplights, and those become IoT enabled as well.
Yeah, I think people don't really understand or grasp how important sensors will be to our lives. And so, I mean, with hardware and IoT, they've always used like Wi-Fi and Bluetooth, and this impending launch of 5G. I believe the IoT hardware community is going to kind of figure out address all these hardware limitations for mass scale and everything. What are some of the software limitations do you see in terms of IoT right now?
So one of the biggest things is bandwidth. As you mentioned, 5G might eliminate that by just having gigabit everywhere. But right now, a lot of rural places, for example, don't have even broadband. A lot of them have dial-up. And if you remember the AOL days, the dial-up isn't so great. So that's one. Another one is actual what data do we collect and how many sensors do we need? So cost. If you're installing 500 sensors that are $1 a piece, that's $500, and that's cost prohibitive to do at scale. Another uh, limitation is computing power. The smaller device, less computing power. Now that's becoming less and less true as ARM architectures are becoming more prevalent, and x86 Intel is starting to get more into the IoT space. But computing power in small devices is very limited. So, for example, if you're taking an image, you only have so much space, so much memory, so much compute power on that device, to the point where you might not be able to take a picture, but if you need a picture to solve the problem, that obviously prevents you from solving the problem. Uh, so the last issue that I see a lot is actually just a basic misunderstanding of a lot of the science already done in the IoT space. And typically, you see a lot of web developers or just general firmware developers going into the IoT space, but they don't understand a lot of the protocols and techniques and algorithms that already exist in the space. So they reinvent the wheel. And so standards are becoming more and more heated in battle, just like they did on the web. And I hope that soon the standards will be as prevalent in the web, like JavaScript. Everyone understands what ECMAScript is. And we will see those standards be ratified, and most of the developer community will hopefully understand them, or at least have heard of them. So when they start working on IoT devices, they understand and can implement the standards.
Is that why it's so hard to? I guess it's really hard to find a firm or examples of where hardware and software kind of work together in IoT right now. Is it because of just the lack of standardization, or is just kind of it's new right now?
It's new. A lot of people don't understand hardware. My dad was an electrical engineer, so I understand hardware fairly well. But a lot of people don't really get it. They don't know how to interface hardware and software, and solutions like Raspberry Pi will help you with those understandings. Absolutely. The other reason is it's just hard. When hardware and software meet, software has its own failure conditions dividing by zero, and um, everyone knows the standard failure conditions for software. Hardware, people aren't sure how to handle when a camera fails or a hardware component fails, or everything's working but no pictures being taken, or the internet goes down. People don't code for that. And so it's really hard to find companies. Apple's a good example of someone that's mostly figured it out. But if you use your iPhone recently, it seems buggier and buggier. As the software becomes more sophisticated, you run into more sophisticated software problems, but you still have those underlying hardware problems. When the Bluetooth controller is acting up or the Wi-Fi controller is acting up, how do you do it? So you're adding more failure cases to an already failure case laden system that's software.
That's really interesting. Well, let's talk a little bit more about just the market itself. I mean, it's going to explode. There's going to be even more, maybe 10, 100 times more demand for IoT devices and developers in this space and designers. Uh, but let's talk about some of maybe the underlying technology in this. Well, how important is open source to IoT?
Absolutely critical. And when we look at standards, a lot of the standards are implemented via open source. When the web first started, open source was barely a thing because no one had a way to communicate. It was just a bunch of people on Usenet chatting about software. With IoT, it's a burgeoning space that is basically started on the internet, on the premise that you can have an internet of things. And because of that, open source is how a lot of Google has their protocols, Amazon has theirs, and they're all open source in a bid to get the most developers to adopt them. And the one that gets the most developers to adopt their open source is going to win this race, and that's their thought pattern. So it's incredibly important. And the ones that have closed spaces like Apple, you can see them already losing. I don't know how many people use HomeKit. I try to stay away from that godforsaken thing whenever I can, but you see a lot of the open protocols, Amazon Alexa, Google Home, getting adopted widely in the home. I mean, go to Best Buy, or don't. Not many people do these days, but when you do, look at all the Alexa-enabled devices because it's an open protocol with well understood APIs, and developers can readily add it and make competent platforms that are voice enabled because of the power of Alexa. And same with Google Home. When you look at Sonos, one of their selling points is that they're both Google Home enabled and Alexa enabled because they're neutral third party. And if you don't have an open source protocol, you should really look at yourself and say, how do I want to win this? Am I going to try to win with a proprietary platform that's better than everyone else's? Or do I want to try to win by just having market proliferation? Apple's trying one way. Obviously, Google and Amazon are going the other.
Yeah, I think it comes down to interoperability, right? You just want to be able to set yourself up so that you can connect to other devices and the network. And I mean, maybe Apple is one company in the world that can try to get away with it. They have so many devices out there. I mean, I think they're always have had this, uh, strategy to make sure everything's all Apple. With Apple TV, your iPhone, everything like that is really designed to keep everything under Apple. So it's going to be interesting to see how that works out. But I think one other thing that open source is really interesting is the speed of innovation. A lot of this is happening at such a rapid pace that we really need these open source code bases to implement a lot of these different technologies.
Yeah, and that's critical. When you open source, you get the entire developer community. Look at Kubernetes, which isn't IoT related, but it is infrastructure related. The project prior to Google open sourcing it didn't exist. As soon as they open sourced it, you saw a mass proliferation of Kubernetes being adopted. In fact, it looks like Kubernetes is going to win the container orchestration space. And they outbeat Docker Swarm, which was made by the Docker company themselves. Apache Mesos, which was out before Kubernetes was. It's really a strategy for making sure that your technology is going to win. You get the entire developer force to like and adopt your technology, then it's hard to lose when you do that. It's definitely a strategy, and I recommend it to a lot of companies. If you're going to have a platform and it's going to compete, IoT or not, consider open sourcing parts of it. You can still keep some of it proprietary, but open source gives you access to a lot of developers you wouldn't have had access to before.
Yeah, and I think it even matters for an enterprise, right? I mean, there's a lot of security there, but it makes sense for an enterprise to open source or use these different open source technologies. Just, I guess, what you're saying, for more compatibility and get more resources to not only accelerate what they're doing, but get the community to help improve their projects as well.
Yep, there's a definite trust factor when I can go and see and audit your code myself. I might not, but putting yourself out there means I can if I wanted to. And that's a huge trust factor for me. I mean, knowing that I could is more than enough to know that you're willing to do that, which means you're willing to put your neck on the line, which usually means you've got yourself covered.
Yeah, interesting. Well, so now you got all these devices that are connected and they're all going to be streaming data. And so you're going to have tons and tons amount of data. Like, what's the first step in handling this data?
Build more data centers. Joke aside, you hear concepts like data lake and warehousing and all of that. I think the term data lake really came about because of IoT. People are getting terabytes of data a day. There's a local company here in Cleveland, Rockwell Automation, that gets nearly petabytes of data a day, and they literally have the more data center problem, where they're collecting all this data from manufacturing companies and they need to process it. So they've come up with a couple techniques. So one of them is streaming. So you'll see technologies like Apache Kafka and others in this speak. Apache Spark's another big one. and they'll help you stream the data out of this basically lake, which is just a raw dump of everything you've collected, and make meaning out of it. So we'll give it to the systems that need to do it. So maybe it's a particular sensor needs to go to a particular system. So then your Kafka or your Apache uh, Spark can stream it to the right handler, and then that handler can put it in the right database. And so basically, it's like a giant sorting problem where you're sorting data to the right systems to make sure it's handled. And you have to make sure you have a high scalable system. So you see people going to the public cloud with Amazon and Google, being the leaders here, Azure as well, and that's because they can handle that petabyte scale already because they're doing it for their platforms. Xbox Live in the case of uh, Microsoft, Amazon obviously has a lot with Twitch and a few others, and so they're able to handle all of these this data load, and you just trust it to them. You're seeing a lot less private cloud simply because of that. It's very hard to build data centers that can support petabyte scale data lakes and data streaming.
Yeah, well, with all this data, I mean, AI and machine learning is going to be even more important. How do you see that fitting into, looking at all this data? What type of intelligence can we implement?
Oh, incredible ton. When you're seeing in almost real time how things are moving in the real world, you can do predictive maintenance on manufacturing goods. So, one problem we tried to solve when I worked at Diebold was predictive maintenance on ATMs. And we actually solved it. And we needed data to do that. A lot of it, to know if a cash dispenser, for example, was going to break before it broke, you needed terabytes worth of data to do that accurately. That's one use. Another use of the AI is just simply um, how are people using their products? If you're Sonos, you care deeply about where they're putting their speakers, how they're listening to music, what music they're listening to, so you can build a better speaker for everyday life. Are people listening to more hip hop? Are people listening to more country? And tuning your speakers and creating speakers that work well for the music genres your users are buying. Uh, I've seen it used all the way to just having the data, being able to profile users. If you're looking at an IoT home platform where you're trying to create a connected house, knowing how people live their lives is an incredibly important task, right? You don't want to turn on the lights when someone's sleeping at 3 a.m. because then they're just going to throw your platform away. I know I would. I would never use it again because it interrupts their sleep. But knowing that I wake up at 6:30 every day, turning the light on, just dimming it slightly at like 6:30 and waking me up gently, well, then that's something I could use. And that's something you can use the data they're streaming from some of my other sensors to know about. And Nest will let you know if I'm in a room or not. So you'll know when I wake up. There's a lot of uses for AI here. I think it's really an untapped market.
What do you think about AI in applications, let's say like shipping, things that are not really um, in the forefront of our daily lives, things that enterprises are using in the background? I've seen like AI uh, being used to improve, like data centers, but like when it comes to IoT, how do you see that playing out?
Yeah, so actually, there's a couple good things here. The first IoT thing is IBM. IBM is using blockchain and IoT devices to uh, verify organic goods. It's really cool. It's a really cool project. They have a couple commercials about it, and you can read about it online via some of their case studies. And they're also using it to predict crop yield via AI and Watson. And so that's really cool as well. So you see a mixture of technology here. Run IoT to supply the data to the blockchain so you know what kind of chemicals were used on your plants, and another to predict crop yield, like how much of this corn in this field is going to be good or how much of this soybean is going to be good. And then another use case is in shipping. We see this used by a lot of the companies we work with, where they have sensors in their trucks to determine, weight of the truck and how the truck is doing, how fast the truck is moving, so they can track in real time about what time they're going to get and arrive. And they do that via GPS, but also so many sensors. You can also predict how much goods, right? So you normally have goods in supply chain that break, and so you're looking at how many goods are damaged during the process, so you can predict and adjust price and potentially adjust quality and shipping measures accordingly.
Yeah, I think you make an interesting point. To me, like the most exciting technology or the combination of technologies is AI, IoT, sensors, and blockchain. And I don't know if any company out there can do all that in one, but I think whoever does that is going to just going to go out gangbusters, because that's like the combination of basically all these technologies that'll help accelerate everything that we're trying to do, and it'll touch every aspect of our lives.
Absolutely. And so that's why it's so important to involve yourselves with people that know this modern technology. A lot of people don't know how blockchain works or how AI works, and certainly IoT, right? And so when you have a company, now I'll shamelessly plug Skipless, that can understand the software part of that for you, then you only have to focus about your problem. And when you're only focused on your problem domain, which most companies are really good at, if you're a farming company, I'm going to assume you're really good at farming. Most farming companies have been around for a very long time. You're then working with experts, and you pair those experts with people that understand the hardware really well. Farming hardware, John Deere, that's the only company I know of, but I'm sure there are a lot of others. You're pairing people that are experts in their field along with yourself, who's an expert in your domain. It becomes magical. And you're right. There's a lot of computer science between IoT. It touches every single area of computer science. Data structures, operating systems, embedded systems, assembly language, all of it. And as you think about it, if you're not a software expert, if you're not software first, as I call it, you may not have all the disciplines you need to execute IoT well. As I mentioned, it's really hard to do just software right. How many companies don't do software even right? It's even harder to do both software and hardware right. It's like you're basically mixing four or five things. You're missing software, which is difficult, hardware, which is difficult, and business problems in general that are difficult. And so how you do it, you're going to need a lot of experts to do it, and you better make sure you're working with the right ones.
Okay, so when you have millions and millions of devices that will be connected, there's going to be a tremendous amount of data flowing through these networks. So the biggest concern is around security. A bit curious, what are your thoughts around security and privacy, and how to think about security with IoT?
So security in the space is really interesting. One, it's not done well right now. A lot of IoT devices communicate over unencrypted channels for efficiency reasons. That's a problem. We need to get the data on the device and the data from the device to the server very secure. Once that's secure, you can start worrying about how you securely store it and respect the privacy of your users. The actual problem here is to make sure you're providing them the best experience. So if you're using AI, how do you collect the data in a way that one respects the privacy of your users and also allows you to provide them a good experience? Now, I think one company that gets it kind of right is Apple. Now, if you get rid of all the flaws of Siri, and there are a lot of them compared to the other voice assistants, they respect privacy the most. And the question is it because they don't have the experts they need to make the voice assistant work as well? Or is it because of the data privacy? I don't think anyone's ever going to know the answer to that, and Apple surely isn't going to tell you. But it's an example of a company that's trying to do the right thing by respecting data privacy and only collecting what they need, and then anonymizing it so that you can feel safe giving Apple your data and having them in your home. Now, I
Well,
feel a lot safer with my HomePods than I do my Google Home and my Alexas.
well, they have a different business model, right? They're fortunate that they have created such a great product business that they don't have to rely on advertising. So like Google and Facebook are they're in a tough position that they need your data. Otherwise, I mean, they're not selling enough hardware. And so I think that's where you see like Google is trying to make a small shift, but it's still the business model is around advertising. No matter what they do with their thermostats or their Google Home, it's all about getting your information. So, I mean, Apple's doing the right thing, but that's their business model. They want to push everything towards the device, and that's why they have these really powerful phones, and they have their own actual chip company that they bought many years ago, because they want to be able to process everything on that device and keep it as private as possible, which I love.
Absolutely. That's one of the reasons you see a concept called the intelligent edge, which is a new term, but it's already lost all the value that the term created. I think Microsoft coined it or something. The intelligent edge is the concept of pushing the machine learning models you generate on the server to do the computing and the actual determination, the predictions from the machines on the devices themselves. It's a really cool thing because it will allow for a lot of privacy to be done, because then you can send the data up and you don't have to delete it, but once the model is created you don't need to really have it available anymore. You can anonymize it, you can do whatever you need to. I think the intelligent edge is the next big thing that's going to really make IoT even better. And we're talking about AI and cloud and IoT there, but it's definitely, if you look into it, something that you should be really excited about, and definitely will be something you hear a lot more about in 2 or 3 years once it's not cutting edge anymore.
Yeah. One thing I do find interesting about IoT is that it's going to create new revenue models as well. You have things like what's that token, cryptocurrency, IOTA. It's basing on like IoT uh, cryptocurrency, and then all the stuff that's happening on the blockchain that you could potentially earn. These different IOTA currencies. And so I think it's interesting that, I don't know how these companies will tie all this in, but you're essentially helping the market use or create a backbone or create a network or layer of all these devices. And so there may be some interesting revenue models that happen as this gets a little bit wider spread.
Yeah, and that's actually a really good point. You're going to see a lot of these primitives, is what I call them, or what they're calling computer science, which is building blocks essentially, be built in the next couple of years that people are going to use to really accelerate their IoT development, creating new lines of business. GE's really expanding their spend on IoT devices because people really recognize the opportunity here, and not a lot of people are capitalizing on it. There are a few really big companies, but they're really being bought up. Ecobee used to be its own company. It got bought by Amazon. The Ring doorbell got bought by Amazon. Nest got bought by Google a few years ago. You're going to see a lot of that consolidation. And so the company that I think a neutral party, the Sonos is a good example here, where they're trying to do their own thing. They're just doing smart speakers. You'll see those people get a lot of popularity. I think people don't really want to fight in a corporate war with these people. They just want their devices to work together, and they want them to work together well. And the more neutral parties, the more people that can build on those primitives I was talking about, uh, they're going to win. I mean, long term, you're always going to see that proliferation. That's one of the good things about capitalism.
Yeah, that's really good. So let's take an example. If you're, let's say, Anheuser-Busch, and you want to be able to track like all these shipments for all the beer, and you want to maybe put RFID tags or some sort of smart intelligence supply chain management. Like, what's a really good way to start a project like that?
I think first you get a bunch of experts in the room, and say, all right, how would you accomplish this from each perspective, the hardware perspective, the software perspective, and the business perspective? You're going to want a lot of business analysts in this room because you want to make sure what problems do we know about already. And that way the hardware and software people can tell you exactly how they might solve it in their individual disciplines. And from there, you build your project team out. I mean, you already have the problems you're going to solve, and you have the experts that know how to solve the problem. And that can be internal, external. Uh, but it's important that as you're building this, what I'll call a cross-functional team, that they're staying lockstep. You can't just put the hardware people in one room, the software people in another room. As we talked with data science last week in our podcast, you have to make sure it's multidisciplinary. You have to make sure these people work well together, and you have to make sure that they know how to speak each other's languages. Because the minute they start speaking they don't speak each other's languages, you're gonna have confusion, and you might have issues, and the project may fail altogether. And it's the same thing when you don't put everyone in the same room. The software people do one thing; it's not compatible with the hardware. The hardware does one thing, but now the software can't get what it needs. It really is important that everyone's in the same room. They're discussing it as a team, and that these experts know how to work as a team. I can't speak. There's no words to describe how important that is. I don't think.
Well, as we kind of wrap up this episode, is there anything that you're thinking about that most other people are not thinking about? Is there anything that we should be cautious over, or anything we should be aware of that's not widely discussed?
I think there's two things to be really cautious over with IoT. One, the hype. Um, for a lot of problem classes, the tech isn't there. It just can't be solved yet. The computers aren't small enough. There's not enough compute power. The broad, there's not internet available. There's no bandwidth. And second is to not to believe that your problem can't be solved either. I think talking to the right people, asking them, what do you think about this? Because the experts will know, you can't solve it now, but give it 2 or 3 years, and here's why. And they'll be able to tell you how to solve it, and you can start game planning ahead and creating a strategic vision around it.
Thanks for listening to the Thoughtful Software podcast. We hope you found it informative. You can always check us out at skipless.com. Talk to you next time.